Right, so everyone, welcome to the February 2026 edition of our community call. As you know, each month in this call, we are looking at we are looking at AKS roadmap announcements. We are also going through some deep dives, feature deep dives, product roadmap. Of course, there's going to be Q&A as well. So that being said, as we start this call, I wanted to do like a quick public service announcement here. Especially if you are relying on the downloaded calendar invite earlier for these calls, you might have noticed that the calendar invite had expired, which probably explains why a lot of people were unable to join the call in January. That has now been fixed, so I would just request if you guys can go ahead, download the newer calendar invite on from the community calls page, and that should continue reminding you of this call each month again. We have a very packed agenda today, but as we just want to take a quick note for some of the housekeeping items. As you all know, this call is going to be recorded. We are going to be uploading it on the AKS YouTube channel. You see the link here for the YouTube channel. It's at the AKS community, and that's where you will find a lot of different AKS content as well. We do definitely encourage you to share these calls more with the community, with the folks that you know, whoever is interested in AKS. The more community, the more discussions that we have, it's going to definitely help everyone here. We are going to have we are going to have an open mic at the end of this call. So throughout this call, we'll have the chat. We also have the Q&A section. If you have questions, just keep posting it there. Feel free to post it there. We will open up the mics at the end of the call, and at that point of time, we can have more free form discussions as well. And lastly, if you have feedback around the content, you do see a QR code here. Flip out your phones, scan that QR code, and you should be able to send us some content. There is also a URL link here, ak.ms/aks/content feedback, and that should also give you a feedback form for submitting your content feedback here. By the way, is the slides going back for all of you? It seems like every time somebody joins, the slides are reloading for me. Is that happening for you guys as well? Okay, if not, that's fine. As I said, it's going to be open mic at the end of the call. So we'll all just make sure that we are keeping these conversations empathetic to everyone joining on the call. It's going to be a lot more friendly and warm conversations, open conversations there. As for the agenda, we will start with some of the announcements. After the announcements, we are going into there is going to be a slight bit of change here. We are going into the deep dive of networking practices, best practices. And then we will also be looking at application monitoring with Open Telemetry. After that, we are going to go into the roadmap highlights. Again, we have the roadmap item is going to be a little bit lighter this month because we have KubeCon coming up next month, and a lot of our updates are usually aligned with some of these big event timelines. So just a month before that event, we would expect a little bit lighter on the roadmap. But yes, we certainly have some incremental progress that continues to happen every month, so we will cover that. And at the end of it, obviously, it's going to be open Q&A or open mic. So that's great. All right, so moving into the announcement, as I mentioned about KubeCon, I see a lot of people are going to be excited. They're going to be at KubeCon here as well. Yeah, I'm pretty sure we'll all see you there. But KubeCon EU is going to be happening in Amsterdam around 23rd to 26th March. If you've attended KubeCon earlier, you would know that every KubeCon, we also have on the first day, we will have what we call as the Azure Day. So this time in Amsterdam, we are going to have Azure Day on March 23rd. If you're attending KubeCon, just be sure to register for the Azure Day. We are going to have a solid presence from our product and the engineering teams. There are going to be a bunch of product announcements that we are expecting. It's definitely going to be very exciting. You can register here. There is a link here, aka.ms/AKSDayEU. You can use that link to register for the Azure Day, and we would definitely want to see you there. On the next announcement, we have the MVP Summit coming up. Um, Unfortunately, the dates for the MVP Summit are actually clashing with the KubeCon EU as well. So on our side, we are going to be kind of tag teaming with some of our team in Redmond, hosting the MVP Summit. Some of us are going to be in Amsterdam for KubeCon. But for those that you don't know, MVP program is a program hosted by Microsoft. It's the MVP literally stands for the most valuable professionals, right? And really, the idea here is for us to connect with our community leaders who are extremely vocal about AKS in the community, who are helping us spread the awareness across the community. So really, the program is aimed at identifying leaders like that and be able to start to strengthen our connections with these community leaders. So if you do have a very strong presence in the community and you're not a part of this program already, we would definitely love to hear from you. Um, and this program does come with a bunch of benefits as well, right? There is Azure credits. Frequently, we do have what we call as product group interactions, wherein our product team would actually bring in a bunch of content. A lot of times that content is not yet released as well. But since the MVPs have NDA, we are able to share a lot more openly about the plans, about the way we are thinking about future features. We are able to get some feedback back from these community leaders as well, and literally influencing the direction of the of the product as well. So there is a bunch of benefits that come with the MVP program as well. Like I said, if you have a strong community presence, you're not already part of this program, just hit me up either on Teams or on LinkedIn, and we'll make sure that you at least we submit your nomination. There is a process for approval that goes after the nomination, but yes, we should definitely be able to kind of help you through that. All right. That being said, I'm sorry, I lost the presentation again. Let me see if I can resume it. We have a small, we have a quick, oh, sorry. There's one more announcement here. We are launching the AKS troubleshooting series. Maya Singh, who is one of our PMs on observability side, she's going to be hosting this. Maya, do you want to probably talk about this series real quick?
Sure, yeah, I'm happy to. Thanks for having me, Sanket, and everyone. My name is Maya Singh. I'm a PM on AKS working on observability, and we really wanted to provide the community with some video content around troubleshooting common AKS issues. So we've started this series that basically brings our teammates, our subject matter experts from the AKS team, whether that's our software engineers, other product folks, also some support engineers will come join us on this series to really tackle very specific scenario-based troubleshooting. So on this first episode, which is already out, actually, Kasim and I talk about DNS issues and some best practices around troubleshooting, the infamous it's always DNS issues. So each week you'll be able to see a new topic. Kills, disk latency, we'll cover scaling and upgrades as well. So we are working on that series, and your feedback is much appreciated. So it's all on YouTube. So you can just put some comments in the YouTube channel of content you would like to see in the future, any questions you might have. That'll help us improve the series as we record more episodes. And yeah, I'll just highlight the last thing is that we're also going to be highlighting a AI-driven troubleshooting approach. So in this first episode with Custom, you'll see he uses the AKS MCP server and the CLI agent, because from my observations and using these tools, they really have like revolutionized the troubleshooting experience. So we want to make sure you all have the best practices related to using those AI-driven approaches as well. So yeah, look forward to hearing your feedback in the comments of those YouTube videos. Thank you.
That's awesome. Thank you so much, Maya. As she mentioned, the first episode is already on YouTube. Just feel free to take a look, give us your feedback. We are definitely looking forward for it. That being said, let's get into the first topic of the day. We have Rutuja here, who wants to just have a quick word about your security experiences in AKS environment. Rutuja, do you want to talk through that?
Yes, thank you, Sanket. So hi everyone. I hope I'm audible clearly, no issues.
Yes.
Okay. So first of all, thank you for giving me a few minutes today. So I'm a product manager in the Microsoft Defender team, and our focus is basically Linux security. We help organizations prevent, detect, investigate, and respond to threats across different Linux workload while ensuring that your reliability and performance is maintained. So, as we know, over the last few years, we've seen security shift quite a bit, especially in cloud native environments. Traditionally, endpoint security just focused on long-lived servers, virtual machines. Today, with Kubernetes and platforms like AKS, workloads are far more dynamic. Your containers are spinning up and down quickly. There's nodes that are scaling automatically. The security is gradually basically shifting from protecting machines to also protecting your workloads that are running on them. So, my point for being here today is to better understand how teams and organizations are thinking about runtime security in this Kubernetes environment. So, things like your visibility across containers, investigation workflows, where security tooling might create friction or feel fragmented. So, most simply, what I'm hoping to learn from you today is where exactly your visibility feels limited, what tools introduce operational friction, and where teams feel less confident from a security standpoint. We feel as if we get some signal, some data from you guys, it will really help us make better platform and endpoint security decisions going forward. So what I'm going to do is I have a really short survey that I've prepared. I'm just going to put a link to that survey in the chat. So if you could take 2 to 3 minutes to just fill this survey. It's really short, just 10, 15 questions. It'll take you 2 minutes. That will be really helpful. So that's a good starting point. And after that, if any of you are interested in connecting with me one-on-one and my team, I'd be really glad to do that.
Right. Thank you so much, Rutuja. All right, so folks, feel free to go through the survey. If you have questions around that, Rutuja would be here as well. We can have a discussion in the chat. We'll proceed to the next item on the agenda right now. We have Diego and Mitch here who will be taking us through networking best practices. Diego, Mitch, do you guys want to go ahead?
Thanks, Sanket. Can you hear me all right?
Yes, I can hear you.
All right, I think I've lost the slideshow.
I lost it too. No, we're on the same page there.
So Sanket, I think we've lost the slides.
Let me see if I can. Can you see it? I can actually move it forward.
I'm not able to see that either.
I can see it actually. Now not
can.
anymore. Yeah, I could see it.
I'm just reloading that. I'm not exactly sure what's happening with the slides. Are you guys able to take control?
I can see the slide that I should now. I don't know about taking control.
I think we can try here to see.
Okay. Well, I'll jump in real quickly and then hand it over to Diego. Hi, everybody. My name is Mitch Connors. I've been a member of the Istio project in various roles since 2018. I joined Microsoft in 2024, and I'm now serving as the product manager for AKS Networking. Really excited to take you through some of the basics of how to get your AKS network off the ground, how to understand the different trade-offs that you're going to be making as you build out your cluster, and then also talking about some of the things that are coming down the pipeline for you. Diego?
Diego Casati from the Global Black Belt team, primarily doing cloud native, so AKS all day, every day. That's kind of what we do here. I'll walk you through the first portion of the slides in here, where we're going to talk a little bit about networking in AKS, and then just so you have an understanding of what that actually means, let's just lay down some foundation understanding here. When we talk about networking, and it could be in various areas here, from the control plane to the nodes, to the pods, and of course, through the applications. Well, let's kind of divide and conquer, because this topic can be pretty heavy, if you will, in different areas. To start with, let's just talk about the control plane networking. How do I get access or control access from my machines or my pipelines to the control plane? In terms of what we see with customers, and I'll tell you for sure here from a global black belt perspective, working with various industries over the past years, there's a few interesting components that we have to keep in mind. First of all, the control plane is hosted by Microsoft. So it is on a hosted environment that we have. It does run the API server, the controller manager, the scheduler, then some other components. And then the way you actually get access through that will depend on how you actually deploy your cluster. Now, the end users, and end users here could be yourself running, kubectl. It can also be just a pipeline, right? The way you access the control plane or the Kube API will vary. Normally, if you have a public cluster, it means your API is exposed publicly, but it doesn't mean that it's YOLO and everybody will just have access to that. You can still control it, and that is one of the things we recommend. If you have it in a public setting, the API can be accessed. It's routable on the internet. We do use connectivity from a tunnel perspective between for the nodes and back to the control plane. But if this is your scenario, you're probably looking for a way to allow through an ACL that we have that enable when you deploy the cluster, so that you can limit the scope of who can actually reach the cluster, right? So that would be the number one recommendation in this case. As we walk a little bit over that, a lot of our customers are actually going with private clusters, which essentially entails that you can see that the whole API is now hosted privately. That IP address is not routable, that CIDR is not routable. You have to have some sort of access to that VNet. So whether that's a jump host, Bastion, you name it, you need to have access there, which means that if you are used to just do kubectl, get nodes or whatever from your location, unless you have some sort of VPN connectivity to that VNet where we have the Kube API hosted, this won't work. Granted, there is a escape hatch that you can do today with the invoke command, but normally for anything in production, you're really looking for a VPN of some sort in there. So you can go from public and then restrict this to an ACL that only allows for certain IPs, very common scenario, or you can go full in private, right? Remember that you need to access that somehow, and it will be typically through a VPN. Now, we also have the API server VNet integration, which essentially provisions the API servers in a delegated subnet. And the interesting thing about this is that you can either use the connectivity tunnel, or, as we're mentioning here, you can do pod access in overlay, or even a bring your own CNI. I'm going to touch briefly on bring your own CNI in a second here. And the cool thing about this is that you can add or remove the API server, whether you not want public access to this without a disruption to the cluster. So that's quite an interesting, it's appealing to have this if you can deploy it. What should I choose? Because I feel like for the CNSF landscape, if you look at, there's so many options. I feel like it's a paradox of choice at this point. Here, what I think you should be using for this is this. Go public if you can. If you have a compelling reason that public it doesn't work, then move down the stack there. Go private. Understand what private means. Understand what you are doing. Normally, I'm going to say right now, it's day 2 operations complexity. But again, I feel like we're doing this we're making this a lot easier now. The AKS PG has released a ton of interesting features over the past years that you can probably just go full-blown private, but evaluate from your team perspective. Do we need public? Is it okay? Yes, let's go with that. If not, keep going down. And then I have the API server VNet integration here, which is available for certain SKUs. So you're going to have to look into that as well. Now, let's move into node networking real quick here. How do I want your cluster to access the internet? So it's a different question than the previous one, which was, how do I access the cluster? Now it's how the nodes access the internet. So what is node networking in a nutshell? This is how the AKS nodes, or our virtual machines, the API server and everything else, access the internet, which could be from a bring your own VNet. It varies from different outbound types. So outbound types is the key word here that we have to look into. The first one, the basic one, is just the load balancer. You create a service, you say the type is load balancer, and then the cloud provider, Azure in this case, will make sure that everything is wired, plumbed together. Once everything works, you have a load balancer with a public IP or private IP. You have an option there too with an annotation. That's the basic one. SNETs are assigned on a per node basis, and you're off to the races. For a lot of people, this might suffice. So you probably can go with that. Now, if that's not enough, and maybe I need more like SNETs because maybe that's what you are, you can use a net gateway. Net gateway can handle a ton of SNETing. I believe it's 65K now. That's the number of ports. Right now, as it is, it's not zone redundant, although Net Gateway just announced that the V2 version is net. It provides zone redundancy. That's not the case with what I'm showing you here today, but you can wire. It takes a lot of work, but you can have a Net Gateway outside and then have that zone redundant. This is for customers that actually need that level of more public IP addresses, and then a lot more ports. So keep that in mind. We're going from the standard to something that can accommodate a lot more with the Net Gateway. And then the third option, again, very common option here, would be to have this with a UDR. Now, what is an UDR? User-defined routing. You're essentially funneling traffic and either to an NVA of sorts, like a firewall, Azure firewall, or another appliance that you want, or a VLAN, and then all your traffic is going there. Normally here, you would have a private cluster with an UDR, and your next hop, instead of being just the internet, so 000 instead of just going to the internet, it's actually going to a firewall for deeper inspection. Very, very common scenario that we see with customers as well. And then you can have a public IP, of course, in your Azure firewall, and that's how you egress with the proper routing in place. What should I choose? Goes with the same saying as the one before. Let's start with the general recommendation. Load balancer, again, should work for most people. High volume, you go to a Net Gateway. Well, what if I need, for whatever reason, maybe I'm in a highly regulated industry that does PCI DSS or HIPAA, I need UDR. I need everything to flow through a firewall, right? You're looking at UDR at this point. The next here is pod networking. Do pods need IP address connectivity, right? How do they actually have that connectivity? That's the question you want to ask. So first thing here, pods, they can have IP addresses on a same flat network or not. It could be on an overlay network. So your question is this: do I need my pods to have a direct access to another IP address on the same network? From here, we have a lot of options. I wouldn't be able to cover this, in 2 hours. So what I'm looking for is a couple of things. Number one, a CNI, which is a container network interface plugin, is really what's going to dictate how this gets configured. The other interesting term here, and it will make sense in a second, is the IP address management, or IPAM. And then normally your routing is going to go through the data plane. Now, let's talk about this for a second. In a overlay networking model, what is going to happen is this. You have a CIDR, which is the pod CIDR, which can be reused across clusters. Just put a pin on this statement because it's not going to age very well in a second. So I'm just saying that you could reuse it. And then you have the nodes, which live in a different CIDR. This essentially means the following. You can scale out your nodes to 5,000 nodes with the Azure CNI overlay mode, and your pods are sitting in a different CIDR. Now, let's revisit my comment about you can reuse everything. And you can see there's actually an asterisk in here too. Why would you not be able to reuse this address space? Well, the reason for that is, what if, and it's kind of common, customers are having their cluster and their VNet peer back down to something on premises, and they're learning new routes through BGP. So the same networking rules that we had when we were doing this in a data center applies here. Make sure you don't have clashing network address spaces. So if you have it, in this case here, right, we have the 10.10.10/16. If I have that on premises and I'm learning that, that's a problem. So the same rules apply, whether that's, again, going on premises, or maybe you're just peering to another VNet somewhere, which we actually block. We'll tell you right now, like, this is going to conflict, but on premises, we might not know. So you might be learning that from BGP. So just bear that in mind. If you don't have that, if it's just everything is in Azure, you're good to go. It's almost a cookie cutter solution at this point, and you just copy and replace these everywhere. The other one is this. You can also have a flat networking model, and the two things you can have here is Azure CNI with a pod or a node subnet. Essentially, what you're thinking about here is my pod, once it comes online, it has an IP address, which is on the same CIDR as something else that I already have, and I do need that direct access. That can happen. If that's the case, the pods can be accessed directly from outside the cluster, right? Because they do get that IP address directly from the CIDR. And from an efficiency perspective here, you have a couple of options. I would say this: dynamic IP allocation for pods. It's very efficient. You don't just carve out the whole chunk of the CIDR. Whereas if you get the pod subnet with a static block allocation, you are eating that whole CIDR from the get-go. Just keep that in mind. From a data planning perspective, I won't drain this too much, but we have either Cilium with eBPF, which is recommended, or the previous generation with IP tables, or the NF tables, which is in preview right now, which does use eBPF as well. So I think the keyword would be eBPF. Look, as much as I love IP tables, I was a Slackware user back in the day. I think it's time for us to move into something like eBPF here. So this is what this is, if the amount of traffic that we have as well. Now, real quick, eBPF-based data planes also allows you to have the advanced container networking services, just because of a few things, including, of course, filtering on layer 7 traffic, like FQDN based. So you could use later on things like Hubble, and also observability. We can actually get telemetry and then have that graphed out on Grafana. So the recommendation is eBPF-based data planes. Now, do we have other options? Of course, we have other options. There are always other options, including bring your own CNI. Always pros and cons. If you bring that, you're kind of on your own. We can't really support you, but you can. We don't stop you from doing that. AKS today, I'll tell you this, has a ton of options that are managed. I think I would investigate those. What do I choose then? Right, I went everywhere with this. Let's go with CNI overlay if you can. It spans a lot. It decouples the CIDR from the pods to the nodes and allows you to grow. Now, if that's not an option for some reason here, go with the CNI pod subnet, right? Because you do have direct pod IP access. Always ask your question, do I need access? And then you can go with the CNI node subnet if you do need that as well, just for simplicity. I always go with like, skip it simple first. I guess I'm going back to my Slackware days, and then add complexity if needed. Which then leaves me for probably the most interesting part of this talk with Mitch, which is the application networking. Mitch?
Thanks, Diego. So if you're familiar with the OSI model, you'll notice that what we've been talking about so far, whether it comes to, or whether we're talking about API server networking, node networking, pod networking, we're talking about mostly OSI layer 3 and down. That's working with IP addresses. Where does a pod get an IP address from? What is the next hop in the route to other pods, to other nodes, or to other resources outside of Kubernetes, etc. When we start talking about application networking, we're really talking about layer 4 and layer 7, where we can talk more about a transport layer identity rather than using an IP address as an identity, and about concepts like hostname for routing control. So let's go ahead and jump in there. At a high level, it's kind of difficult to describe application networking, but it's really an abstraction that is more fit to your application than to individual compute units or pods running on individual nodes. We start talking about an application, we would say, well, I don't really care which nodes this application is running on. Maybe I don't even care which clusters this application is running on. I'm going to give this application an identity. And wherever it runs, it uses that identity, and then I can write policy against that identity to describe what the application can and can't do, how to route traffic to and from the application will also be identity-based, and that identity will also be used for gathering telemetry, things like metrics and trace spans, etc. Lastly, we also use some of the same abstractions for exposing the application outside of the cluster, and we'll look at that next. So we've talked a little bit about load balancer services in terms of network topology, mostly in terms of egress. That's because an Azure load balancer controls both egress out of a VNet as well as ingress to the VNet. So on the ingress side, the load balancer service provides layer 4 load balancing. If you're familiar with Kubernetes, then you're used to just creating a service of type load balancer, and you automatically get what we call an SLB in front of your service. It gets a public IP address and port that users can hit to access your service inside of Kubernetes. This is super simple to get started with, but it does have some limitations. You do need to provision at least one unique IP and port pair per application, and you are billed for those IP and port pairs directly. We also have a limit of 300 IP and port pairs in a single application that you can combine. So then you might, if you're needing to expose more than 300 applications in a single cluster, you might need to start looking at more complex topologies like multi-SLB, which is currently in public preview. Probably the more common friction to run into here is that HTTP clients commonly use or reuse their TCP connections. And because this is a TCP load balancer, the TCP load balancer doesn't see this reuse. It just sees I got one TCP connection, and so I routed it to this person, and then the next TCP connection, I routed it to the next pod. In those cases, if those two TCP connections have a different number of requests, let's say one of them is reused across 1,000 HTTP requests, the other is used for only one HTTP request. From the load balancer's perspective, those are equal. Those are both one TCP connection. From your application and pod's perspective, it's probably not equal. You're going to see extremely heavy load on the one pod and light load on the other pod, and you'll wonder why you're not distributing that load evenly. And that's when you might want to start looking at a layer 7 load balancer. We call these ingress controllers. These run L7 reverse proxies. Common solutions around the industry would be Istio, Trafic, Nginx, which we'll talk about a little bit more in a bit. Usually most interesting for HTTP like traffic, although it can work for TCP as well. You're going to be able to reuse a public IP and port for all of your services that are represented by an ingress controller. Instead, you're going to differentiate or distinguish these requests by HTTP constructs like hostname, path, headers. That's going to be how you're going to route to different pods on the back end. And you do get that wonderful per request load balancing characteristic of a layer 7 load balancer, regardless of TCP connection reuse. So your client speaks HTTP2, that's just fine. You're still going to evenly distribute those requests across backend pods, and you should see a much more even load distribution. I've got a little bit here about our managed ingress options, but before we get to those, I want to talk a little bit about Ingress Nginx. How many of you have heard of Nginx, the Ingress Nginx deprecation? I just realized that in this venue, I don't know if I can see a show of hands. Oh, I'm seeing thumbs up. Awesome. Okay. So we've got some work to do if you're using Ingress Nginx. By the way, this is the most common ingress controller in the Kubernetes ecosystem. For years now, the Kubernetes ecosystem has been slightly shifting strategy. The Ingress API that is behind Ingress Nginx and other popular controllers from early on in the Kubernetes ecosystem still remains, but it's frozen. There's not any improvements being made to the API. It's not deprecated. It's not going to be removed, but it's also not getting better over time. It's not going to evolve to fit your needs. Instead, the Kubernetes project is recommending adopting the Gateway API. The Gateway API does the same thing Ingress API did, but with a different API shape that makes it much more easy to secure so that you have different roles that say create an Ingress gateway versus attaching routes to an Ingress gateway. Much more appropriate for enterprise use. So what do we do with those two trends? The Ingress Nginx has been deprecated and the Kubernetes ecosystem is moving away from the Ingress API altogether. Well, at Azure, we have historically offered a product called Application Routing, which was built on the open source Ingress Nginx controller. We are also deprecating that. However, we've given you some options to migrate to. Actually, I'm going to take these in a slightly different order than I wrote the slides in, because this is what everyone needs to see. If you're using just upstream Ingress Nginx, that is retired at the end of this month. As of March 2026, it will no longer have any security fixes, and you can expect that there will be vulnerabilities very quickly in this project. If you're using the application routing with Ingress API, which of course is built on an Azure product built on Ingress Nginx, we have extended Azure's support policy through November of 2026. So we bought an extra 8 months where Azure will provide only critical security patches for this product, giving our customers a little bit more time to migrate to one of the supported solutions. And then of course we have 3 supported solutions, one of which is generally available today and 2 of which are starting in public preview at the end of this month. So now I'll go back to explore those 3 options you have for migrating on AKS. We have actually 4 supported Ingress products moving forward. We do have one that is built on the Ingress API within Application Gateway for Containers. You can see that at the bottom here. We're not recommending migrating to this, even though it's a fully supported product. The migration from one Ingress controller to another is a complex migration. The APIs, even though they both use the Ingress API object, the Ingress API is, in all practice, it's mostly annotations that mostly don't carry over from one provider to another. So if you're going to go to all the work of migrating from Ingress Nginx in one form or another to something else, you might as well also make the leap to Gateway API. We don't think that that creates additional pain or friction. So up at the top here, we have our 3 supported Gateway API providers. Obviously, Application Gateway for Containers. This runs your data plane outside of your cluster on Azure Managed Infrastructure and has a lot of great integrations with other Azure constructs. So if you want to put a web application firewall and program that from inside Kubernetes, that would use Application Gateway for Containers. You're also going to see a billing meter associated with using AGC. So that's something to consider in your adoption. We then have 2 in-cluster options that are more closely associated with open source. There's the application routing add-on with Gateway API, which under the hood is actually going to use Istio, but none of the mesh features of Istio. So you won't see any sidecars, you won't see any Z-tunnel, you won't have any control over east-west traffic, but you'll use an Istio Ingress gateway using the Kubernetes Gateway API to get traffic in and out of your cluster and control that. Then, because Azure also supports a managed Istio experience, if you use the Istio Service Mesh add-on, you can also use that with Gateway API to get traffic into your cluster. Effectively, you're getting exactly the same experience as the application routing add-on, but also with those east-west controls, sidecars for full MTLS automatically throughout all of your cluster. So those are the supported experiences moving forward. And we would encourage you to migrate to one of these. Obviously, there are open source alternatives as well. If you're currently using upstream ingress Nginx, would recommend planning your migration as soon as possible. If you're using the application routing add-on, you have until November, so there's no need to panic, but you do need to start planning that migration now, working with your support team to make sure that you're going to be able to migrate smoothly. And you can expect more documentation for step-by-step instructions on how to migrate in the near future as we publish these alternatives. All right, lastly, when we talk about application networks, a lot of times we're not just talking about getting traffic into your cluster, but actually traffic that's already in your cluster, moving around inside of it, or going between one cluster and another. In this case, we want to provide those same controls that Ingress or Gateway API have historically provided, not just for traffic coming from outside the cluster to inside the cluster, but for all of your traffic. This provides things like FIPS compliant encryption for all traffic inside a cluster and outside a cluster. Within a multi-cluster environment, you also get things like dynamic failover. You can say things like, if 10% of my requests to a given service get 404, go ahead and evict that instance of the service and try another instance instead. Might be another instance locally, might be another instance in a cluster in an adjacent region. You can also, using the MTLS encryption, you can write MTLS-backed policy. Things like Service A can only send GET requests to Service B, or perhaps Service A can send POST requests, but only to a certain path in Service B. And again, because these are application layer abstractions, they're not working with IP addresses. There's nothing under the hood that's saying, well, I know this IP address maps to this service, so I'm going to apply this policy. Rather, it's using mutual TLS on the wire, the same way that you would use TLS when you authenticate to a banking program using HTTPS, using that same identity to make policy-driven decisions about what access is allowed or denied. And lastly, in-cluster and cross-cluster traffic controls are going to give you end-to-end metrics, logs, trace spans through telemetry. And all of this is launching in a product named Redacted. I don't have approval to share the product name with you this morning, but I can tell you that there is a public preview or a set of public previews coming next month that are going to explain not only the product name, but your options for migrating and onboarding. So keep a close eye on that schedule. All right, to sum up this section, what should I choose for my application networking needs? Well, this gets pretty complicated and it depends on the needs of your customer. If they need something super simple and super fast to get traffic into their cluster, you cannot get simpler than just using a load balancer type service. It's incredibly fast. If they need more nuance and scale, like being able to approve certain routes for certain identities and disapprove and reject others, or perhaps to expose more than 300 services in a single cluster, expose multiple services under a single IP address and host name, you're probably looking for a Gateway API ingress controller that we discussed earlier. And if they're looking for a turnkey, production-ready global application network, they should look for Project Redacted. Again, look for that name in the coming month. All right, I think that's all I had for you. Thanks for your time and attention. Feel free to share any questions in the chat and I'll try to get to those.
Right. Thanks, Mitch. Thanks, Diego. In the interest of time, I know there are a few questions in the chat here. I think in the interest of time, we should probably just proceed to the next one. And if you guys can respond to the questions on chat, that would be helpful. Next, we have Coyote here talking to us about application monitoring using OpenTelemetry. Coyote, do you want to take control and try your luck with the slides right now? I know it's behaving a little bit finicky. Sorry about that.
No worries. Let me try to share my screen. Can you folks hear me and see my screen okay? Sanket, you might need to share my screen.
Yeah, I cannot see the screen, but let me try to reshare.
There we go. All right.
Yeah, there you go.
Thanks everyone for joining. My name is Coyote. I'm a product manager on the Azure Observability team, and I'm going to discuss with you how you can use OpenTelemetry with Azure Monitor today. So the headline and the takeaway from this slide is Azure Monitor now supports ingesting OTel metrics, logs, and traces directly from your applications and platforms. So this means today you can stream OTLP directly from your OpenTelemetry SDKs or your OTel collector to Azure Monitor endpoints. Now you can automate how you set up Azure Monitor to collect this OTel data by using application insights. Application insights can orchestrate all of the endpoints, data collection rules, and storage that you need, and provide application performance management experiences for troubleshooting, diagnosis, RCA. That's one option. Alternatively, if you are more interested in using open source data visualizations, like you want to write your own Prometheus queries, you want to visualize in Grafana, or write your own log queries, we allow you to do both of these, accessing the OpenTelemetry data directly, either using Grafana dashboards built into the Azure portal, your own standalone Grafana, Azure Managed Grafana, as well as log analytics. We'll have new tables that are OTel specific. So I'll spend a couple minutes here talking through the architecture of how this works. On the left side of the slide, this is your application and your compute platform, and you can choose how you do your instrumentation and data collection. You can use the open source vendor neutral OTel SDKs to instrument your application once and then redirect those signals to whatever data collection and APM tool you choose. Or you can use the Azure Monitor OpenTelemetry distro. This is our flavor of the OTel SDK with Azure-specific capabilities. Now, how you collect and send that traffic to Azure Monitor, again, is up to you. You can use the open source OTel collector, or if you're running on Azure Compute, like AKS, VM scale set, you can use the Azure Monitor agent, which has the ability to use managed identity for auth, one of the major advantages there. Now, the OTel data, OTLP signals, are then sent to Azure Monitor. So the right side of the screen talks about how you set up Azure Monitor to do this data ingestion and visualization. You have 3 endpoints, one for metrics, one for log, one for traces. And this collects the OTLP signals. Then there's a data collection rule that determines where these signals are routed. So metrics are going to be routed to an Azure Monitor workspace. This is backed by Azure Managed Prometheus. So all of your metrics live in here and can be queried using Prometheus endpoints. And then your traces and logs get sent to log analytics. And beyond that, you have a choice for how you visualize, consume, monitor, triage, troubleshoot your OTel data. You can use built-in application insights experiences that are now powered by OTel, or you can use Grafana dashboards. And we have a couple of flavors of Grafana available. Grafana baked into the portal, Azure Monitor dashboards with Grafana, or Azure Managed Grafana. So how you set this up on AKS is, first, you need to enable cluster level monitoring. So as part of the AKS cluster, there's a monitoring blade. You go to monitor settings, and we have lots of options here for full stack monitoring. Infrastructure monitoring for your CPU, memory, etc. And those signals are collected and sent to an Azure Monitor workspace. Prom queries, you have your container logs and events sent to LA, your dashboarding options. And what's new, what we're just opening up our preview for, is the ability to enable application monitoring. Today, you need to set up both your Prometheus and your container logs. In order for this option to work, they reuse the same Azure Monitor agent. So these two become a prerequisite for your application layer monitoring. Now, once you've enabled this at the cluster level, you can then pick a specific namespace, and then you point that namespace to a given application insights resource. So for the next part of the presentation here, I'll hop over into the Azure portal, navigate to an AKS cluster, and we'll just walk through the setup here. Under the monitor blade, I'm going to go to monitor settings. And this is where we'll see our options for setting up our Prometheus or container logs. And the new option, once you've enabled both Prom and container logs, is application monitoring. And that's going to be the last option at the bottom here once this page loads. All right, so in this cluster, I have all of the options checked. So I get infrastructure metrics, container logs and events, Grafana dashboarding, as well as my application monitoring. Once this is done at the cluster level, you can then navigate to a namespace, and then you point your namespace using the application monitoring preview to a specific App Insights resource. Now, if you create an App Insights resource that is OTLP enabled, like I have here, we'll get an option for instrumentation type. Instrumentation can be done in one of two ways. You can use auto instrumentation for any of our supported languages. In public preview, we have support for Node and Java. In private preview, we have support for .NET and Python. And auto configuration is if you've already instrumented the application with the open source SDKs. Once your application monitoring is set up, this requires a rollout restart. So you need to restart the deployments. All of the instrumented microservices will show up in this list, and then you can start consuming your App Insights info, both from App Insights or from Grafana directly. So I'll spend 2 minutes talking about the consumption experiences and application insights. So all of your APM signals, the metrics, the logs, the traces get sent to App Insights. App Insights is backed by a metrics store, Azure Monitor Workspace, and a logs and traces store in Log Analytics. And then all of the views, whether you want to troubleshoot things like your performance. When you see a spike in response time, you can click and sweep to highlight it, pick a specific range of transaction durations, and then look at specific samples for end-to-end tracing. So application insights gives you a full APM experience, but instead of being based solely on proprietary application insights SDKs, all of this data is being powered by OpenTelemetry data collection in the SDK, as well as the OTel collector for forwarding or the Azure Monitor agent, and you get your standard application insights experiences around failures, performance, and so on. Now, if you'd like to do your query construction, like you want to write your own Prometheus queries, you want to write your own logs queries, we have two options here. First, I'll go to dashboards with Grafana. This is our Grafana experience built into the Azure portal. And we have some out-of-the-box dashboards for OTel specifically. So for this App Insights resource that I'm collecting OTel data, I can start with one of these out-of-the-box dashboards, in this case, OTel metrics for HTTP-based services. And then we can edit the queries here to see what queries are actually being run and how they're being sliced and diced by service name or service namespace or path. And lastly, the application insights resource here, because we are making it enabled with OTLP, it has a logs workspace, a metrics workspace, and my OTLP connection info. If you want to directly send your metrics, logs, and traces to these endpoints without using any of the Azure Monitor agents or Azure Monitor OTel SDKs, you can simply point your OTel collector to these endpoints directly. And once you have Azure Auth set up, we'll ingest that data, and you can query logs directly in the Log Analytics workspace, which will now have specific tables for OTel, OTel events, OTel logs, resources, and spans. So I will try to keep things on time by simply pointing out that in order to get all of the benefits of OTel on AKS, the easiest way to do this is to create an App Insights resource that is OTLP enabled. This will create your data collection endpoints, data collection rules, the storage in Azure Monitor Workspace and Log Analytics Workspace, provide you the out-of-the-box Grafana dashboards. All of this is done automatically if you're using an App Insights resource that is OTLP enabled. If you do not, you'll have to manually configure and orchestrate those entities yourself to do the data collection. All right, I'll pass things back over to you, Sanket. Thanks for the time today.
Thanks, Kayode. Let me present. Actually, you know what? I'm gonna do what you did and just present right from here. Let's see if I can do that. All right, so I know we are almost at time. If there are questions around around using OTel with Azure monitors, feel free to drop them in the chat. Coyote will be here to answer those as well. Um, let's see if I can bring my screen up again. All right, there we are. So we're going to spend really quickly. We're going to spend some time on the roadmap. As I mentioned, the roadmap is fairly light, thankfully, today. Very quickly, just a quick disclaimer, if we are sharing any of the timelines on the roadmap, it's note that it's subject to change unless it's a GA, unless we are already talking about GA. So as we get into roadmap, we are getting close to KubeCon, which is where we will actually have a bunch of updates next month. This month, we are bringing you some incremental updates, mostly related to NAP, the node auto provisioning. There has been a lot of incremental progress happening on NAP. The NAP team has been busy bringing up parity to several features from node pools. Earlier, if you know, we had several restrictions when using NAP on existing clusters, or even some of the underlying node pool features on the clusters managed by NAP itself were not possible, right? So with this parity gap being closed, a lot of those restrictions are now being lifted off. So as you can see here in this list, with the NAP managed clusters, now you are able to use encryption at host, encryption set support, the disk encryption set, bring your own keys or CMK, however you like to call it. We are able to use local DNS, custom CA, and the HTTP proxy support. So all of these underlying features are now available for our clusters managed with node auto provisioning. And lastly, with deployment safeguards, as you might be aware, upstream Kubernetes has some pod security standards set up. And usually these are set up because we've seen that security misconfigurations are one of the biggest causes of container breaches across the industry, right? I mean, not just with Azure, but generally across Kubernetes. So really the pod security standards help bring a lot of uniformity on the container security posture. And like I said, this is across all clouds. So think about AWS, AKS, GCP, across all clouds. Wherever you have Kubernetes, these security configurations or uniform security configurations do apply, right? So the deployment safeguards are now validating each and like every workload against these security standards. So your baseline policies would block your dangerous privilege escalations, and then the restricted policies would enforce maximum hardening there. I know we have Amanda on the call. Amanda, anything else that you wanted to add on the deployment safeguards?
No, not at this time. Trying to think. Yeah, no, not at this time.
Perfect.
With
No
AKS
problem.
automatic deployment safeguard is turned on to enforcement mode, so all of those policies are being enforced by default. So we want to continue to enforce those best practices. But do let us know if there are specific policies that you're running into trouble with, and we're happy to discuss that offline.
Awesome. Thank you so much, Amanda. All right. That being said, I do have some deprecation announcement, but these are the same as last month. So if there are any questions in the audience, especially we have Coyote still online, we have Amanda online. If there are automatic related questions, you guys should be able to come off mute and have that discussion now. Okay, we have a question from Tobias. Deployments safeguards currently do not support custom policies. Do we have any plans? Amanda, you want to take that?
Yeah, yes, that's correct. It currently does not support custom policies. Underneath the hood, though, deployment safeguard uses Azure policy. So I do think it's possible for you to build your own Azure policy to create those custom policies.
Tobias, does that answer your question? Feel free if you need to have more discussion. Awesome, thanks. All right, if there are no other comments, I'm going to drop a link of all the a list of all the links here in the chat, and that way you have everything like a reference of everything that we talked about. And thank you all for joining. I know we went a little bit over today, but thank you for your patience, and see you all next month. All right. Thanks all.
Thanks.
Take care.
Thanks a lot.
Thank you.